Hello everyone. Today I'm going to give a demo of multi-class classification of Alzheimer's disease. So in this project, we have collected the data set of different types of Alzheimer's disease, and training is done through the neural network, and prediction is done through the GI part. So now go for the code. So this is the data set we have collected. And you can see the moderate demand. So this is how we have collected the data set. This is the training code. So these are the libraries we used to train the model. So initially we have collected the different types of Alzheimer's, like we have collected the four diseases, and after that we are loading the data set. And once we loaded the data set, we have convert the each image into the array conversion, and after that split the data set into the train and test and validation. Once the splitting is done, print the model like print the categories and also images and training images and also test images once it is displayed. So in this part we have it will display the image into the RGB channels. After that it will convert it into 3D, and next it is converted into 4D, and this part is used for to display the graph. This training is completed. So this is the model. So this is the defining the model. So that here we are used two layers of convolutional. And for in convolution theory, we have mentioned previous convolution size and also shape of the input size. And second is activation. The activation here will be used and max pooling. And similarly, second layer. Once the second layer is defined, here it is flattened to convert two dimension into one dimension. After that, softmax is used for classifying purpose. So after that, we are compile the model, and model compile it will display the accuracy and loss. And compilation is done. Fit the model, train tensors and train targets. And run the model. So you can see the type of diseases of Alzheimer's. Total 706 images are there. So here till 8 iterations. It keep on training. Parallelly, you can see the accuracy and also loss for each image. So once the completion of 100 iterations, the training process is completed. So now we can see the 56 iterations is going on. So you can see that's the completion of 100 iterations. We display the graph of accuracy and along x-axis, along y-axis accuracy. Here we can see the training accuracy and calculation accuracy. So parallel you can see the graph of receiver operating characteristics. Go for the testing code. So these are the libraries for to if used to create the GUI and this for to creating the buttons. And this is useful to read the images where file dialog is used to select the image from a particular folder. After that, once we display the original image, gray image it will display. And here we used K-means cluster for the segmentation. After the classification is done through this model. Now click on run model. So this is the GUI part of multi-class classification, Alzheimer's disease. Click on load image. Select any one of the image from these diseases. Processing, segmentation, prediction. So we can see predicted image is non-demanded. Finally, we check for another input. Complete processing, segmentation, prediction. Here we can see predicted images moderate demanded. We can check for another input. Select any one of the image from this pre-processing, segmentation, prediction. And see predicted image is very mild demanded.